Yes. So we are live. We wanted to talk today. So now the second part of today's will be the microscoping, Micronaut under the microscope session with Graeme Rocher. And Graeme is here. You can see him on the screen. And today we wanted to talk. You wanted to talk about the annotation interceptors.
Yeah, method interceptors.
Method interceptors. Excellent.
So I thought we could have some fun with interceptors and see what we can do with them, and in their different forms. So it could be a lot of fun.
Right. Okay. Let's do that. I'm eager to learn, and I'm sure the people watching as well.
Absolutely. Okay. So I'm just going to share my screen. Give me a minute. Okay, so I have a Micronaut project here in VS Code. And so we're going to look at interceptors. So what are interceptors and what would you use them for? What are the different types of interceptors you can do and interception models? So fundamentally, you often have logic. So I might have an example of Java being here, and hopefully I can make this into an example, right? And define it as a bean, and maybe we have a method like just called test that gets invoked and output something, or maybe we should return something. Return hello world. Okay, so this is a pretty simple example. I can inject this into my application, to my test here, and call test. We get a result. And this will be essentially my results, right? So I'm going to just write some equals logic here. Hello world, just to set up a simple hello world example that we can exercise and intercept and so forth. So we can run this test, and the test passes. So my simple component is implemented. I'm just going to check if I can increase the font size a bit here, maybe so you guys can see things a bit better. Okay, there we go. So here's my example. So say you wanted to apply some logic around this particular method, some kind of logic that has to wrap every time this method example is called. So in typical case, if you were not using a framework, you would have to write some custom logic before this, some custom logic after this, and repeat that. Maybe you could use lambdas to wrap it around or do it each time, but essentially you have to apply some manually applied logic each time a method is invoked. So the point of method interceptors is that I can invoke this kind of intercept this method call and apply some additional logic to that method call, either before or after the invocation of what ends up being the result, right? So the way we can make this happen is, for example, we can create a not null.java annotation, and it can be in the com.example package, and let's call it it's going to be a annotation, not null, like so. And we have to make it retention runtime, like that. And the only thing we really have to do to You may want to customize the target, for example, make it only applicable to methods or whatever. But the only thing you really have to do is add around to this annotation, which says that this annotation is going to apply what's called a round advice. So it'll decorate the invocation. Then you need an implementation of this. So what you can do is you can create a new not null interceptor, for example, and it can be in the com.example package, and it's going to be a not null interceptor. And what you want to do is implement the method interceptor interface, like so, and implement the intercept method. So a method interceptor basically just has a single method that you have to implement, which is called intercept, that gets past the context, the method invocation context. And then the final thing that you want to do is bind this interceptor to the particular annotation that you want. So what you do is you can add an interceptor being and the particular annotation that we're interested in intercepting, which is this annotation that I've defined as part of my code base. So now every time not null is used, for example, if I add this here, like so, and I run my test again, coming in here and running my test, you'll see that the test actually fails. You can see the failure here with unsupported operation exception not supported yet. So that's because my interceptor is being triggered, and it's intercepting the method call that has been decorated with not null. So, like I said, with interceptors, you typically want to add logic before or optionally after the method invocation. And the way you do that is through the context object. So if I were to just do a no-op interceptor would basically be context of proceed, right? So if I do context of proceed here to proceed with the method invocation, and I run this test again, I'll be back to green because it's working. It's not a particularly useful interceptor because it doesn't actually do anything useful. But because I'm implementing this not null interceptor, which is basically going to prevent a null return values. So we're going to say if result equals null, throw new or we can just do something like this. Objects.require non-null result. Method illegally returned a null value, like so, and the context.get description. There we go. Okay, so why is that right?
You need one more parenthesis, closing parenthesis.
Yeah. I should really split that onto multiple lines and make it better. I'll just, I don't know. There we go. Okay. Maybe I would have been able to read that a whole lot better if it was like spread out. There we go. Okay, so going back to my test then, if we run this interceptor, it's still going to pass happily. But if we were to add a method that returned null instead of, and actually it's my ID, it's already detecting that this is called not null this annotation. So that's actually quite useful. I didn't know I was going to do that. So my ID is giving me a nice little hint saying, I shouldn't be doing what I'm doing right now, but I'm doing it anyway. So let's run it again and see what happens. Okay, so we get the error method illegally return a null value, string test, etc. So the get description method provides a nicely formatted string of what the method looks like in code. So you can see that it's a string test and it legally return null. So that's the most simple example. And as you can see, this is actually like after advice. So it's applying some like logic beforehand. So actually executing the result, and then applying some logic to it, which is nice. But if you wanted to, like, for example, let's just roll this back and do say hello string name, like so. If you wanted to apply this interceptor, because you're really paranoid about having nulls in your code anyway, to method arguments before the invocation, you could do the same thing, right? So you could say context, get arguments, and get all the arguments for the method. And there's actually that'll return the actual argument types, but probably it's easier to get argument values map, probably the easiest. Okay, so there's map all my parameter values like so, and params. And what you can do is params or for each name value, something along those lines. And in here, what we can do is say objects require not null value, method passed null value illegally, or something to that effect for parameter name. See, what's missing semicolons. I suppose if I could have removed the semicolon if I'd made this a lambda expression. Here we go. Okay, so there we go. So now we're like validating these arguments. So if I were to pass in John here and run this again, once again, we will get a nice test passing, I imagine. But if I were to pass in a null value in here, we can see that we get the exception method pass null value legally for parameter name, which is really nice. So now, one thing that's really important to remember is that proceed can actually be invoked multiple times. So this calling proceed just this once, will return the result and execute it a single time. But you can actually call proceed multiple times. So for example, I could do something crazy, ridiculous that you would never do, like this, and call context.proceed plus context.proceed. Well, something along those lines. Probably I need to concat it to a string or something to make this work. Doing evil Java things that you should never do. But yes, basically you can do that. And if I run this again, you'll see that the test result was hello John duplicated twice. Now, clearly this is not a good example of that, but the use cases for this are, for example, you can do things like implement retry. So you could have instead of not null, this could be a retry annotation, and you could invoke the method, catch the exception, retry the invocation up to X number of times, before to implement like really simple retry logic using AOP interceptors. So that's important to keep in mind, that you can invoke proceed multiple times. The other thing is that Micronaut has is this ability to detect. There's this type called Intercepted Method, and you can use it to construct a context object like so. And it allows you to apply, some specific logic to based on the result type. So, for example, I can get the result type. I can do a switch statement, result type, like this, and add some case, and you can see that it'll automatically work out, because sometimes you need to implement interceptors that handle synchronous cases, handle reactive cases, handle completion stage, and they can end up being very complicated if you have to repeat the logic for each one. So Micronaut has some built-in knowledge of how to handle the synchronous case. Otherwise, you can say default, which just says throw new unsupported operation exception, method return type not supported, or something along those lines. There we go. Okay, so that's an example of using this intercepted method type to automatically deal with different return types. So why is this useful? So let's have a look. So this is handling the synchronous case, right? So if I run this and execute it, probably my test will pass. But what if I had another method here which had something like not null, completable, completion stage, or something like that, and I did completable future completed, I think it's completed. There we go. Along those lines, completed future. And this method was called test async, right? Okay, so this has some like hypothetical logic here that handles asynchronous calls, right? So if I were to invoke this method in my code, and let's add another test, the test async case. So then you would do example test async, which is actually not async whatsoever, but anyway, and probably to make this test easy, I'm instead going to just return a completable future type. Okay, so there we go. So now I can do a completable future dot get and throws clause. Just add exception there and throw anything. And extract that into a variable result. And then let's just copy that over. Okay. There we go. So now I have an async invocation happening. That's just blocking until thing completes. And you can see that it throws method return type not supported, that's because it came into this other block, which is to handle the case where something is a completion stage, which I don't have. So what you can do is if something is a completion stage, you can say, I am handle intercept completion stage, like so. Result as completion stage, I believe. Like so. And right, so the result is completion stage. And what you want is, in this completion stage, we can completely handle the logic completely differently. So, you know, I could, for example, just cast this to a completion stage for the moment, and then do something like then apply and have a function here that basically checks the result is not null, right? So something along these lines. Objects, I don't know, result, etc. Why is that not getting to apply? Variable result is already defined. I see. I'm dealing with.
Just call it something else.
Yeah, just call it something else. Async result.
Oh, I would go with for result 1, but
yeah, whatever. Okay, something along those lines, right? Let's not overcomplicate our lives. But essentially, yeah, you can handle the completion stage result appropriately, proceeding, you know, then apply and checking the emitted result is not null. So you can, based on these different cases, and we have another case as well for reactive. And given, you know, my challenge of the completion stage in this video, I'm probably not going to even attempt reactive stuff. But basically, yeah. Now if I run this, like so, and all my tests are passing, and my interceptor is being applied. So, you know, Micronaut's intercepted method API as well is a really nice way to basically automatically have some intrinsic knowledge about different result types, like synchronous cases, completion state cases, reactive cases, and automatically handling those in interceptors, which I think is pretty cool. Okay, so that's like basic interceptor development. And what we've looked at so far is a round advice, right? So a round advice, as I said, you're decorating a method call by wrapping its invocation in additional functionality. And an important thing to remember as well is I can have multiple of these. So I can have 2 interceptor beans that both match the notional annotation and provide different behavior. You can control their order in a number of ways. One way is to add the ordered annotation, and specify a order, which is just a number. And we have another way is to override the get order method, which I think is on this class here. So extends interceptor. Yeah, interceptor extends ordered. So there's a get order method that you can override and provide an alternative implementation that supplies the order from the interceptor itself. And you can position your interceptors in the orders, in the particular order that you want. There is also a interceptor phase, intercept phase, I think it's called, enum, which has a number of different phases: async, cache, retry, trace, transaction, validate. And all of these enum values have particular positions. So if you wanted to position your interceptor in a particular place, based on the different phases of interception that exist out there, the interceptor phase enum is what you're looking for. Okay, so with that, I'm going to move on to the second type of AOP advice, which is introduction advice. So like I said, around advice, we decorate a method call. Another type of advice is to introduce additional behavior. So what I'm going to do is I'm going to create a new annotation here. Let's call it, I don't know, stub.java, whatever, and put it in my com.example package again. And let's make this a stub. And again, we're going to add retention, and it's going to be runtime retention, like so. And this time, instead of around advice like we added before, what we're going to do is add an introduction advice. So what is introduction advice? Introduction advice is different to around advice in that instead of decorating behavior, you're introducing, you're implementing abstract behavior, essentially. So where could this be useful? So let me create my interceptor and I will show you. So I'm going to create a stub interceptor.java example. Stub interceptor implements method interceptor, like so. And once again, we can implement the methods in this. And just for the moment, throw my exception. And again, we can add interceptor beam and add stub.class, like so. And there it is. Okay, so here's my stub interceptor. Here's my stub annotation. So let's for the moment make this class abstract. And if I make it abstract and I run this test, probably it'll just fail with a no such bean error, because basically my bean is no longer it's abstract and it cannot be instantiated or put in. But if I were to add my stub annotation to it, right, and I had some kind of abstract method here, test abstract, like so, and whatever. And let me run my test again and see if this works. Okay, my test is green again. So now the stub annotation has turned this from being an abstract type into a concrete type by allowing the abstract behavior to be implemented by interceptors. So if I were to add another test here, let's say test introduction, and I do example test abstract and invoke that method, and I run this test, you'll see that we get that unsupported operation excepted because it's not supported yet, because my stub interceptor is hit here. So where is this actually useful? So this is useful and used in many places in Micronaut. So the most common one is that probably a lot of developers have been exposed to is Decorative Clients. So you know how in Micronaut you can basically do a client and something like that, and example, and then you can define an interface like so. my client, and you can define a GET request that invokes some endpoint, and something along those lines. And this will basically implement automatically for you all of the client logic needed to produce a string from invoking that endpoint. This is exactly how introduction advice works, right? So I can actually inject my client into this test. And I don't actually have an example endpoint in this application yet, but if there was, I can invoke it, and all of this functionality would be automatically implemented by what is the HTTP client introduction advice. So HTTP client introduction advice is a method interceptor that basically intercepts this method call and builds an HTTP request and sends it out exactly how this particular stub interceptor is doing. I can return some random result here just to make my test pass. You can see that if I introduce a field, this is my result, and whatever, random. There we go. Okay, so if I run this now, you see it passes, right? So it's hitting my my stub interceptor, which is returning random, and my test is asserting that it worked. Obviously, you would never do this because this is so simple, and there's all sorts of problems with this. But it serves to demonstrate what can be achieved with introduction advice, which is all about introducing new behavior. Okay, so I think one other thing I think is probably worth covering is introduction advice also allows you to specify additional interfaces. So for example, if for some reason I wanted to make my the target class runnable, you'll see that so I've just specified stub runnable, and you'll see that now if I can add so true example instance of runnable, and I have introduced the run method, the run interface into my class, right? So I have made the example class implement runnable at runtime. This is useful in a number of different ways. You can adapt functionality or make something into something else, and all sorts of things. If you need to integrate with third-party systems and introduce functionality, some frameworks and libraries require you to implement certain interfaces, and you can make that just a matter of adding an annotation and integrate with that third-party system easily. Okay, so that's pretty much what I had to demo today. Any questions? Have we had any questions from the audience? Oleg?
We don't actually. I don't think so. At least they are not typing them in chat, which is where they should be typing the questions. I think that was very elegant, and I can definitely see that being useful in various scenarios. You just, I don't know, like you can, like it's like the hammer, right? It's like the hammer that once you are shown it, right, you can build all kinds of absolutely magnificent things with it, right? It's, I don't know, a round advice or something, like you can see that, I don't know, like you can, I don't know, the only imagination is the limit for that, right? You can implement all kinds of retries, you can implement all kinds of like reloadable policies for configuration and whatnot, right? This is just whatever you want, and it all comes together in a very very neat package.
So there's some canonical examples of this being used obviously I'm demoing very simple things, but like in Micronaut, if you do not blank on a parameter to add to activate JavaX validation constraint support, this will automatically trigger the validation interceptor, which is just one of these guys that intercepts this method call and looks at all the parameters and the annotations on them and applies whatever validation rules that you may have. In this case, not blank, you could have like a size constraint or whatever on maximum length of the name, whatever. And multiple different validation constraints can be applied here, and we intercept that and so forth. And then of course the canonical example, which most developers are aware of, is at transactional. So Micronaut data allows you to do at transactional here and apply transaction management for the scope of the method call, which is automatic rollback, etc. When errors happen and so forth, which is very useful, as you say.
Right, and this is I think the one part that I think I would emphasize, because I just realized that again, and then I was like, this is really cool. The annotations are coming from random libraries, third-party libraries, and you just write the Interceptor, so you sort of integrate with the third-party things this way.
Absolutely, yeah. So one thing that maybe I have not demonstrated here, but basically you can, in this case, I'm annotating this annotation around, but you can also apply interceptors to existing annotations at compilation time, whether it be JavaX,
you just showed it here,
or some
right?
specification. Right, exactly, yeah. So you can apply to interceptors, and also we support JavaX transactional. So that's an annotation from a specification. And what we do is you can define what's called an annotation mapper, and you just map it to the interceptor binding and apply method interceptors to existing annotation types, which is pretty cool, I think. And Micronaut is very flexible in that sense, and all happens build time in terms of computation.
That is a very cool addition as well. Right, I don't see any questions in chat. Any questions from people on the call? Probably not.
One of the things that is nice about doing everything at build time is all of our interception logic is reflection free. So if I add a breakpoint here and if I debug this particular test, you'll see that when I hit this debug point, and you can see here's my stack trace, and you can see that did I write the run? I think I wrote the async one. Anyway, it doesn't matter. I'm running the test async case, and you can see that the stack trace is very short, right? So this is my code that is getting invoked, and there are 3 frames before my interceptor is triggered. Only 3 stack frames. This makes it a lot easier to debug because in traditional frameworks that rely on reflection and runtime bytecode generation, these kinds of stack traces end up being huge with loads of reflective access and internal stack frames that are really difficult to read. And obviously we can also optimize performance a lot better by the fact that the JIT only has these 3 frames to optimize in terms of JIT compilation. And that's, the reason being is, Micronaut is fundamentally build time and builds these reflection-free invocation handles for these things.
Nice. Those shallow stack traces are an excellent idea.
Mm-hmm.
I think so.
Yeah. If you've ever seen the stack traces from other
I have a related question.
Yeah, go for it. But,
so on your annotation, your not null annotation, you said that the retention was runtime.
Yeah.
Why is that if it's all compile time?
Because Micronaut does respect source versus runtime retention. So if it's source retention, it won't store it in the runtime metadata. If you see what I'm saying. So you can still access annotation information, right? So for example, if I go back to my test here and run this guy, you'll see, and say for example, I want to, I don't know, customize the message or something like that. And I want to customize this kind of prefix or something like that for some reason. So I can stick this in here, right? And now I have a member on the annotation that I want to read, right? So what you can do is from the context object, you can say context.string value not null class, and the name of the member, the default is value, so this will be message, and then that'll actually return an optional if you wanted to actually get the default value. You can, there's another method called get required value, but basically for the moment I'm just going to use this. It's probably easier. Pass it in there. Probably it's best to have that in a constant or something, but anyway, for the moment I'm just going to do this and introduce a variable for that. So there's my message, which I'm getting from the annotation. And once again, because Micronaut, is reflection free, you can access all the annotation metadata through the context object without, falling back to reflection. And we can concatenate our message from here. And now if we run this and make my thing return null again, so you can see the failure. So if we run this, we will get the failure of the message being illegally whatever. But I could come in and I could come into my example and I could say message something else and provide that value to the interceptor. And now you can see that the message is something else. So I've customized the message through the annotation. Now, if not null was source retention, then you would not be able to read this value because it would not be passed to the runtime part of the Micronaut. Hopefully, that's quite a long way to answer your question.
Cool, thanks.
Right. Very
Okay.
cool. Very cool.
Yeah.
I have one more topic here, and I'm gonna introduce it. It's a big day today, right? It's a big day today. So I want to preface this question. It's a huge day today. The new season of Fortnite landed today, and we are very excited about it. Kidding, of course. The season is here, but the big thing for us, of course, is that JDK 16 is also here.
Right? Of course, yes.
So I just copied here the features that are the JEPs, the features that are highlighted on the download page for the JDK 16. And there are a number of internal ones and a number of like infrastructure changes, like migrating to GitHub. So personally, I distilled that into like the four that I'm not actually showing. I don't know if you can see it. I don't think you can see it. Right now, maybe you can see it in my camera. Right. So I distilled it into four that I'm excited about. So the Alpine port, the pattern matching, for instance, of the records, and the encapsulation of the JDK internals by default, which is I'm not sure what's the impact of that. But here's the, if we talk about the list, can you maybe provide some idea, what are you excited about that? What of those are relevant or very interesting for Micronaut, for example? And what JDK 16 means for Micronaut?
Yeah, I mean, there's a number of things I'm super excited about. From the infrastructure ones, the migration to GitHub is just going to make things so much easier to browse the code and create PRs and all that kind of stuff. Obviously that's not like language level, but that's just exciting by itself that, the JDK is on GitHub, and it just makes it easier when everything else is on GitHub and to collaborate and support. So that's a big plus one for me. But in terms of the other features, there's a number that I think have important significance for Micronaut. In fact, I am doing a presentation at Oracle Developer Live soon on Micronaut and records. So we have really great support for JDK 16 records, and I think records have the biggest potential to kind of reinvent Java APIs since Lambdas, in terms of the way that people think about API design. And obviously records are closely linked to pattern matching and instance of, and I think that there's a lot can be done. And I think promoting immutability by default, final by default, those kinds of things, records are going to have a huge impact. And we have in Micronaut already a lot of scope records. So you can define configuration properties as records. You can use Micronaut data JDBC to read and write objects to the database as records. We have integration with Jackson or JSON, integration with the B intersection stuff, so you can instantiate records. And we built compile time copy constructor support for records as well. So we have a big story around records with Micronaut, and I think they're a huge feature. And beyond that, the foreign memory access API is, I think it's an incubator in this release, but I think it has a big significance in terms of, previously Netty and libraries like it, have been using unsafe and so forth, which is clearly in the com.sun package. But with acknowledgement that's is really a required use case and important for frameworks like Netty and Micronaut to support native from memory access and so forth. And the fact that it's coming in an official way to the JDK, I think will be a big deal for such important kind of infrastructure tools for the server-side development and like Netty. So I'm interested to see how uptake of that will happen in the future with Netty, whether it be Netty 5 or a future version of Netty. I think that's going to be an important feature to see where it evolves and so forth. So certainly foreign memory access is a big deal.
No, yes, those are the long-standing projects. I think the foreign memory access is codenamed Panama.
Yeah.
Right, and it's been developed for several iterations now. So hopefully it will get to the kind of logical conclusion.
Yes, I hope so too. I would love to see that in JDK 17 in final form. But
right.
We'll see.
I don't think there will be, personally, I don't think there will be like do you think there will be like a migration of tools and libraries for that? Because currently everyone uses JNI, right, when they need to.
Yeah.
And some libraries use like kind of constructions on top of JNI, like JNA and JNR and some others, right? So we have like
I don't think there's going to be a mass migration out the gate, because so many of these will have to, tools like Netty and so forth will have to continue to support Java 8 and Java 11 and for many years to come. But certainly it's good that there's going to be a way forward. Unsafe was even used in the Groovy language as well in places, which is shouldn't have been done. But dynamic languages also have use cases for unsafe and so forth. So the fact that interesting to see where that goes, and looking forward to see how that evolves. But certainly for me personally, records coming out of preview is a big deal for this release.
Right. Does Micronaut use any JDK internals that will be strongly encapsulated by default? Like non-critical internals, like unsafe, everyone uses unsafe. Just like in the previous hour, Doug showed how the Graal compiler uses unsafe for various things to speed things up, right? So that is not a question, right? But in 16, this encapsulation that was introduced back with modules, I think in 9, and there it was like illegal access is permitted by default, and like you just get a warning, which I assume most developers ignore it, because developers ignore warnings. That's just how we are, right? So do you think Micronaut applications will kind of struggle with this upgrade, or?
No, we don't use we don't have illegal access anywhere in Micronaut at runtime, and we have been testing Micronaut on JDK 16 early access releases for some time. So there is one place where we do use it, but that is not in the runtime; it's in the compiler. And the reason we use it, we use it in the compiler is because there is a problem that's fixed in JDK 17, apparently, in terms of write performance when you're writing binary data from an annotation processor. So it essentially wraps the binary data in a filtered output stream, which produces write performance. So we actually had to reach into the internals of JDK to unwrap the filtered output stream before writing it, which is as a complete hack, but the only way we could get that particular performance optimization, which improved compilation time by 3x in our case, to work on earlier versions of the JDK. Right. So there are cases like that, and I imagine there's many cases in different libraries and frameworks where these kinds of hacks exist in terms of optimizing things and so forth. But in the case of Micronaut, Micronaut doesn't use at runtime anything that produces warnings. So we're good.
And the compiler you run yourself, like the framework runs itself, right? It's not like people run it normally from the outside. So you can still like specify that illegal access permit, for example, and change the behavior back to how it is now in JDK 15, for example. So I don't think that would be an issue.
Actually, we can't actually, because the compiler is essentially Java-C, and Java-C. So Micronaut loads, it hooks into Java-C through annotation processes, and Java-C doesn't support the illegal access warning flags.
Right.
Although it's written in Java, it doesn't support those flags.
So what I'm hearing, there should be a different distribution of Java-C. How interesting.
So yeah, so for us, we can actually disable those flags for Java-C. For that particular case that we're using, providing a workaround to an issue that we encountered.
Okay.
The good news is that if anything exception-wise is thrown, it falls back to the slow path. A bit like when you write that JavaScript code that tests if something is undefined and falls back to doing that kind of thing. So it's a fairly non-invasive thing. Yeah.
Right. There are how familiar are you with other JDK, other JAPs? So the interesting for me are, for example, that I want to talk to you about next is maybe the Alpine port, because Alpine Linux is something that people use when they want small
images,
containers, right? And then also there is the kind of sort of related to the packaging tool, which I have no experience with. But if you have, maybe does it either of those matter for Micronaut, or do you see people using them in the wild a lot?
So Micronaut is used in lots of different contexts, and there are some people that are using it for include even JavaFX applications and desktop applications and all sorts of things. I think that things like JLink, and I'm not exactly sure. I haven't looked at all in detail of what packaging tool means in the context of JDK 16 here, but certainly it could be important for some people using Micronaut, because Micronaut is used in cases where people are using the module system, or in cases where people are building desktop apps or CLI apps, or as well as now in the case of microservices that are built with Netty and so forth, it's probably less common because people are typically for packaging using fat jars or Docker containers or that kind of thing. But certainly the Alpine Linux port could be relevant there if you're running, if you want to run the JDK on Alpine Linux, to obtain smaller images with the JDK. So that's a big deal.
Right. Yeah, and it's very good that it's kind of sort of in the main line now, but because I know there are some distributions out there who kind of provided those binaries, but it's very good to have it in the sort of the thing. Right? Very well. I don't think I have very many other questions. Do you have general comments on JDK 16 or something about that? Say something nice.
Well, super excited that it's here. My only hope is that there please be a Gradle release that supports it soon. Or I think there is a 7 milestone that supports it or something.
Yes, I've seen that 7 should support it, and Maven works, right?
Yeah,
Maven works already.
Yeah, Maven works. Yeah. So that's the thing we're keeping an eye on the progress of Gradle towards 7.0 that supports JDK 16. And Maven works. And I believe you can also use Gradle because it has this new Java toolchain API thing where you can use a different JVM like to run Gradle than you use to build your app. So you can build Java 16 apps now with Gradle, where Gradle itself is running in Java 11 or whatever version. Of Java
I see. You can struggle with Gradle in Java 16 and still build for Java 8.
Yeah.
That sounds
exactly.
No. That is cool. The build tools will join absolutely, and this is I think people will migrate to 16 eventually. 17 probably more likely. Right.
Yeah.
Any other questions to Graeme? Chat. Tell me something. Sealed classes. Do you have any experience with that?
I have not. I mean, I watched a presentation on them, and they look very interesting. I have yet to think about where I would use them. It certainly looks like a promising feature, but I'm looking forward to. I certainly have not played with the sealed classes as much as I've played with records. So, one of the things with developing frameworks where we still support Java 8 is I spend most of my day writing using Java 8. But unless I get to touch a new JDK feature like records, which it looks pretty cool. But certainly sealed classes are the next thing I will be looking to explore how we can support better in Micronaut for sure. Or if we need to do anything for that, probably we don't.
Right. Yeah, I don't think there's many changes needed. It's a base feature, just
No.
like you have to find a use case for that, and then when it fits, you're gonna use it. Right. Yeah, thank you very much, Graeme, for being with me here, and I like the Interceptor API and how it looks and how powerful it makes you feel. Because you can change things very easily, and thank you for that. And yeah, JDK 16 is here. So I think what we're gonna do next with the Twitch is we're gonna raid Nikolai Parlok, who recently joined the Java Developer Advocacy team.
Oh wait.
Right, so
that's exciting.
He is streaming currently the Java 16 release party, right? So going over features and everything. I think it will be interesting for our people watching here. So I'm gonna do that, and before they all leave, thank you, Graeme, and see you again next time.
Absolutely. Speak to you soon.
Yeah. Okay. Thanks.
Take care. Bye.
All right. Right. So what we're gonna do? We need to. Right. Let's do the main camp before we go anywhere. Right. Thank you everyone for being with me here. That was interesting. The next session will be on Thursday. The GraalVM streaming week continues on Thursday, and that will be a very native image heavy session. So there were 2 presentations, 2 time slots. We're gonna talk about what native image does at build time and how you can influence that, and sort of the best practices, how to use different tools. And then there will be an external guest, very interesting person, Sebastian Deluze, the Spring Framework committer and the lead for the Spring Native project. And Thomas and Sebastian will chat about the implementation, the status, the trade-offs, and everything around using Spring as a GraalVM native image. So yeah, that's it for me now. I'm gonna try to rate Nikolai and say hi there and enjoy. I think it would be a very interesting stream about the features in JDK 16. Let's try to do this. And yeah, we can go there. Twitch is doing something. This is my first time creating a raid, so we're gonna raid Nikolai now. Thank you, and see you on Thursday and the next week.